But we're going to add a couple of 3s and 4s to our deck that we're working on. And when we multiply by 3s and 4s, that's our skip counting. So we're going to practice a couple of those. So it's not all of them, it's just a few of them, but let's talk about it. So we multiply 3 6 times, right? 3 times 6. Then we're skip counting 3. 6 times 3, 6, 9, 12, 15, 18. Okay, that's 6. So 3 times 6 equals 18. What's 3 times 5, Mason?
If it adds 18, go up.
Down
3.
by 3.
Down 3 more, add it.
3, 6, 9, 12. Good. David, what about 4s?
I know that.
8, 12, 16, 20, 24. So 4 times 6 is 24. 4, 8, 12, 16, 20, 24. 4 times 6 equals 24. Libby?
3. Wait, 0 times 3 is 0.
Good.
28.
Whole sentence, please.
4 times 7 equals 28.
Good.
5. 4 times 5 is 4.
4, 8, 12, 16, 20.
20.
Yeah. 4 times 5 equals 20.
4 times 5 equals 20.
Good.
4 times 4 equals 8.
4, 8, 12.
16.
So 4, skip counted 4 times equals 16.
I thought 4 was 50.
Oh, it's not 4 plus.
So if you wanted to short, if you wanted like 4 times 4, if you wanted to like simplify it, you could do 4 to the 4 squared.
4 squared. Yes, would be the same. Very good.
3
times 7. So
3 times 7 is 3, 6, wait, 3,
9,
3, 6, 9, 12, 15,
18, 21. 3 times 7 equals 21.
3 times 7
And
12.
good. Whole sentence.
3 times 4 equals 12.
Yes. So that said, I'm not adding any new notations because we're still doing. We're still working on what we have. I know that your group is adding more, and you are more than welcome to continue practicing because we still need to work on the ones we have. I am not introducing new ones right now. Okay. So let me ditch about half of these since we already did that. All right, Mason. Remember, when we multiply by 10, we just take that 0 and we add it. Not 18. We put it at the end. That puts our 8 in the tens place and our 0. 8.
10 times 8 is 80.
Good.
10 times 10 equals 100. 10 times 3 is...
What's 3 groups of 10? 10, 20.
30.
What is it?
30.
10 times 3 equals 30. Wait for your turn and don't interrupt and steal all of people's answers, please.
1 times 12 equals 12. 1
10 times 14 equals, add a 0 here, and we have 100.
104.
Good.
104. 9 times 2 equals 18.
Good.
0 times 2 is 0.
Good.
0. Intersection.
Intersection. It includes elements only elements in both sets.
I did that on purpose.
They're not mixed up. We just finished our multiplication. Now we're in. Which domain is this? Nope. Which domain is that? C is for complex.
Complex.
I did not flip it to the other side. You're right. It's okay though. We're just practicing a couple of them. Mason, what domain is this? Reels.
Reels.
R is for reels. Good. What's this one?
Greater than or equal to.
Good.
I know. By.
Almost.
Bicep.
Nope. Beta.
Beta.
Sorry.
Data.
What's this one?
The
Everybody.
square root of 2 equals approximately 1.414.
Good. All right, Mason. Let's put our pencils down so that we're paying attention to the symbols. Fahrenheit. Degrees Fahrenheit. And we use what temperature measurement?
Degrees Fahrenheit.
We use Fahrenheit. Good. What's this one, David?
Degree.
Dimension.
Is it dimension or dimension?
Plus or positive?
Kelvin.
Minus.
What?
Angle brackets.
Angle brackets. Parentheses. Good.
4 ways to say multiplication.
Plus or negative. Plus or minus, positive or negative. All right, everybody, what's this? Radix point and base 10 called a
Decimal.
what's this one?
Therefore.
Subset.
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 Superset.
Yeah, subset or equal.
Subset or equal. Good.
Delta.
No. Indefinite integral.
Indefinite integral. Good. Let's call this. All right, so we're starting a new week, week 4. We have some artwork, Leaping for Lily by Kate Gilpin. She's the daughter of the author, Christy Gilpin. Well, one of the authors, Christy Gilpin. So her daughter drew this artwork, and that's kind of cool.
So basically said like this was actually she like put it up she made this on a computer.
Nice. All right, so what mathematical concept are we dealing with this week?
Addition and subtraction.
Addition and subtraction. All right, Ayla, will you read the Antoine de Saint-Exupéry quote?
In anything at all, perfection is finally attained. Not when there is no longer anything to add, but when there is no longer anything to take away. And that the
Antoine de Saint-Exupéry.
exupéry.
I am no longer my own, but thine. Put me to what thou wilt. Rank me with whom thou wilt. Put me to doing, put me to suffering. Let me be employed for thee, or laid aside for thee. Exalted for thee, or brought low for thee. Let me be full, let me be empty. Let me have all things, let me have nothing. I freely and heartily yield all things to thy pleasure and disposal. And now, O glorious and blessed God, Father, Son, and Holy Spirit, thou art mine, and I am thine. So be it. John Wesley. So in that quote, we heard a lot of opposites, right?
Let me be full, let me be empty, let me have anything, let me have all things, let me have nothing, and that kind of.
It does. With addition and subtraction, those are opposites. It's okay. It's just a fun. All right. So how does this artwork make us think of addition and subtraction? David? Look at the chart.
This.
Ayla?
The lily pads, they kind of look like a number line with this jump.
Yeah. The frog reminds us of our hops. Libby?
The frog.
What about it? Makes you think of.
It looks like a frog that's
Okay.
They're
Right.
like different groups of birds. They're like one bird, 5 birds, like 2 birds.
If you turn your book like this, it kind of looks like a hawk split.
It looks like, yeah, the birds look like the hops because they're curves. Very nice. Very nice. How many birds are there?
I know.
9.
Oh.
How'd you get that many?
You added it.
You added the groups, right?
You can also,
Libby, how many trees are there?
And
How did you know?
Because you added.
Because you added the groups. Mason, how many lily pads are there?
I know. 5.
Actually,
So
there
you
are 4
added,
and a
right?
half.
David,
Half.
if we have 5 lily pads, but only 2 have flowers, how many don't have flowers? 3.
2 and a
How did
half.
you know?
Because when I was looking at 2, I also saw the one in the corner of my eye, so it popped out in my head.
And because we know if we have 5 and we take away 2, that's how many? 3. Alright, go ahead and open to I2. Are you following instructions?
Nope.
Alright, what dimension are we in this week? Do your chevrons. We're still in the first dimension, right? Addition is when we are increasing on our number line, right? See how our hops are moving forward on the number line? Whereas subtraction is when we're decreasing on our number lines, right? What do you see that looks familiar? Do you recognize anything?
I live in autistic groups.
Nice. That's I3. We're working on I3. You're also on I3. Yes,
diagrams.
Okay, so we see some Venn diagrams on I2. We're on this page. Do you see anything familiar?
Number lines.
Number lines. What do you see, David?
Greater than or less than greater than.
Awesome.
X is greater than X is less than A. X is greater than A.
You're right. Keep going. I was not going at you.
A is less than X. X is less than B.
Very good. All right.
We're
and,
4 dimension. No, 3 dimension.
yes, we are in 3 dimension. Okay, at the bottom we have arithmetic and linear space is the subject, dimension description for first dimension. Why? How are addition and subtraction notations on the number line? How do they relate to each other on the number line? How do
They
addition and subtraction notations on the number line relate?
They don't.
They do. Which direction is addition going? It's going to the right. Which direction is subtraction going? The left. Are those the same or are they opposite? They're opposite. So how do addition and subtraction relate to each other on a number line? They're opposites. Okay? Yep. Alright, go ahead and turn to page 1. You go ahead and work independently while I help others. The very first thing we're doing, please don't. Yes, you can mark off flashcards. Alright, so on this very first sentence, we have 1 plus 2 equals 3. When we're adding, each digit that is in the expression or the number sentence has a special name. The add-in are the 2 things that are being added. In this case, the add-in is 1 and 2. Do you know what the number 3 is called? What's the answer called? Look at where I'm pointing and read.
Less than. Some.
Sum. So when we add, we have our add-in, sum. Add-in, sum. But that's only when we're adding. When we're subtracting, they have different names. The first one is called the minuend. The second is called the subtrahend. And the answer is called the difference. Difference, right? So when we subtract, the first number is the minuend. The second is the subtrahend. And the answer is the difference. See that? Minuend, subtrahend, difference. Please trace your vertical hop. Yes. How do you read this, Mason?
0.
I.
0 imaginary number.
Nope, just say I.
0 I plus 3.
Say I.
Plus
Equals
equals
30.
30.
Yeah. Right? Which question?
There's one. Usually there's one.
There's 3.
They go
Yes.
3.
So here we're doing 1, 2, and we're just showing one hop. We're not stopping on the way. Yes?
Do we trace this?
Yes, you can trace your vertical hop. Mason, what did you do here? What does this say to do?
It says
Add.
add.
So first we add 0 plus 3 equals.
I know.
Libby, say with us. 0 plus 3 equals 3. And then we trace our hops that show that. If we start at 0 and we add 3, we can add 3. Alright, pause. It says trace and then add a plus. Adding means plus, or then subtracting uses minus. Okay, so trace your first sentence. We have 8 minus 3 equals 5. But look at this next one. 8 plus a negative 5 equals 3. How does that work? Which way does negative go? Okay, look here. We started where? We started at what number? We started at 8, and then we add. But add tells us to go which direction? To the right. We get bigger, right? But what happens when we add a negative 5? Negative tells us to go which direction? Yes, David. Negative tells us to go which direction? Left. So we go 1, 2, 3, 4, 5. So when we add a negative, we have to remember that we're paying attention to our signs and go the direction that they tell us to, right? Okay, what's that last number sentence?
3 negative positive 8.
5.
Oh,
So we
3
have
minus plus 8 equals negative 5.
So where are we starting? Where are we starting? What do we start with?
3
3.
negative 3.
Okay. No, not necessarily. We're starting with 3, and then we're doing what?
Going to 8.
We're adding or subtracting?
Adding.
Hold on a minute. Three minus positive 8. So 3. When we see 3 minus positive 8, we don't. A positive 8 can be left kind of like by itself. So we're ignoring that positive sign. So it's 3 minus 8. So are we going left or right? Left. So let's go left 8. 1, 2, 3, 4, 5, 6, 7, 8. And what does that give us?
5.
So 3 take away 8 or minus 8 equals negative 5. Y'all tracking on that? Alright. Trace your fractions and color the equivalent sections of the circle. So how many does this tell you you're supposed to color from the circle? 2. 2 out of 6. Go ahead and do that. Trace the rest of your fraction sentences, please. Yes?
So definitely 2 out of 8. It says color 1.
What now?
It says color 1.
No. It says 2 6 equals 1 6 plus 1 6. Make sure you trace the whole fraction before you move on to the next one, okay? That's how we train our brains right. Here we have how many? 2 out of 8, so color 2 out of 8. Mason, do the next sentence. And 2/8 equals what? 2/8 equals 6 pieces, you need to color 4 of them. Alright, and this says you need to color how many pieces? Make it neat. And fix this one. How many are you supposed to color?
2.
How many did you color?
3.
Okay. Alright, this says simplify. Look here. Stop picking at your tongue. 3 minus 2 equals 1. Remember, when we have 2 negatives, that's the same as a positive, right? Okay. Here we have 3 plus a negative 2. Remember? But if we start at 3 and we add negative 2, where are we going? Left or right?
Left.
On 2. So 3 plus negative 2 equals 1. Alright, let's look at that last one. 3 minus 2 equals, right here. 3 minus 2 equals what? What's 3 take away 2?
Yep.
And then positive 3 plus negative 2, here again, same thing. Positive 3 plus negative 2 is 1. 1 here. And then that last one, our double negative is the same as a positive, right? So double negative 3 minus positive 2 is 1. Alright, trace your indefinite intervals. Here you have 1 indefinite interval plus 1 indefinite interval equals how many? 2. So you're supposed to write 2 in the left, right? 1 indefinite interval plus 1 indefinite interval equals 2 indefinite intervals. And then trace your symbols. Okay? In the top we have a word problem. I have 315 cubes. If I give you 2 cubes, see how we took them away by crossing them out? How many cubes do I have left? What does 315 take away 2? We have 300. So we put 3 in the hundreds place since we still have our 300s, right? We still have our 1 group of 10s. Write our 1 group of 10s. Here, write it. If you write it out, it's easier to see. How many groups of hundreds? 3. So put your 3 in the hundreds place. How many groups of 10s? 1 10. And how many ones? No, we don't write we only write the 1 in the tens place. We don't write 1 0. Okay? Because the 0 takes the ones place. And how many are in the ones place?
3.
3.
So 1.
So what's the answer?
313.
313. Alright, trace your
Number line.
equation and number line. Mason, since you already traced it, how do we read this?
1 plus 1 is more than.
What side? Is this the bigger side or the smaller side? This is the bigger side?
Smaller side.
Yeah, so it's less than. 1 plus 1
Is
is less than
A,
which is
3
less
less
than 3 plus 1. And this is how we would write that on our number line, right? Okay, we're going to color here. It says color 2 rows. Pause, Mason. Everybody set? Goodness, excuse me. Everybody eyeballs up here. So they like you're working on it.
Yes.
When you have a graph and it's a bunch of boxes, this is not that pretty. Okay, when you have a graph that has a bunch of boxes, you see this? Because this is what it looks like. I don't know if that's the right number or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, when you have a graph like this, if it's going up and down, that's called a column. Think of like buildings have columns to hold them up and they stand up and down. Right. And then left to right is a row. Okay, so this would be a row. So when it says, ladies, color 2 rows, we're going to color left to right, not up and down. So on that first problem, color 2 rows. What is the up and down one called? Up and down is called a column. Left to right is called a row. On the second one, you're going to color 3 rows. Color 3 rows. And then go ahead and trace your number sentences. So see here, we started with 4, so that's 40. And then we took away 20. We took away 2 rows. And we had how many left? 20. No. 40 take away 20 is what? 20. I think you skipped to the bottom one. 40 take away how many? I got you. I mixed you up. Sorry. 40 take away 30 equals 10. All right. It says trace and add. The summation symbol is this weird pointy E-looking shape. Can you say sum? Sum. That's the symbol that means sum. The summation symbol means to add a sequence of numbers. We see that the first number, n, is equal to 1, and the last number is the one at the top, equal to 3. So what's 1 plus 2 plus 3? 4. 1 plus 2 plus, look, 1, 2, 3.
6.
Yes. Summation means we add the whole sequence. The sequence means going in order. Don't forget to trace your n equals 1 because that tells us what number we start at. And then the number on top of the summation symbol tells us where we end. So we started with 1, and we did the whole sequence with 2, and we stopped at 3, right? All right, trace and simplify your addition down below. Now pause, do this with me real quick, please, because it's important to math that we go in order. So if you're going all over the place, you're going to get confused later. When we are adding and we have more than one place value, we always start adding which place value first? Do you know?
10.
No. Opposite. We always
45.
Alright, you're guessing the answers. Pause and listen to what I'm asking. Right here, what place value is this? This is the ones, right? And what place value is this? Tens. Right? Ones and tens. We have 2 columns that we need to add. We always start with the ones place first. Okay? So, we're going to add 1 plus 5.
50.
We're not mashing it together. What's 1 more than 5?
6.
6. Okay? So that's how we do that. 1 plus 5 equals 6. Write that down on your first. And we're doing the same problem. Now, we're going to add our tens groups. Where it says 1 plus 25. Right there.
Mom, I know it. It's 10.
Yes. So our tens, we have 2 groups of tens. So what I want you to do as you do your next 3 problems, you always start in math with the ones place first when we're adding this times value versus that.
So do we just trace?
No, that's the opposite of what I'm saying. Start with the ones place first. The ones place, not the tens place. So when you write right here, you have 30 plus 12. Are you going to, which number do you write first? The ones place. Write the ones place before you write the tens place. Trace your ones place. Stop, Mason, and listen. Trace your ones place before you trace your tens place. No. See how this says ones, tens, hundreds? I want you to trace the number that is in your ones place first. Then trace your tens place. Then you trace your hundreds place. Trace your ones place. Then you trace your tens place. Then you trace your hundreds place. In reading, we start on the left and we go to the right. But in math, in this situation, when we're adding multi-digit numbers or subtracting multi-digit numbers, we start on the right and go to the left. Okay? All right, we're comparing using our greater than and less than symbols. Which one is greater, 30 degrees Fahrenheit or 90 degrees Fahrenheit? 30. No. 90. Which one's greater? Bigger number. 90. So we would read this, 30 degrees Fahrenheit is less than 90 degrees Fahrenheit. Yeah?
Sure.
Okay? Excuse me.
Yes, please.
You need to check your attitude and be respectful.
Yes, please.
What is 15? Take away 15. Because we have to solve this last one before we can answer it. What is 15? Take away 15. 0. So this side is equal to 0. Write a small 0 on this side. Help you remember that. All right. On the other side, we have 15 plus 0. What is 15 plus 0? Here we have a 0. What is 15 plus 0? David. If you had 15 cookies and I took away 0, how many cookies would you have? Yes. So write a small 15 on that side. Now that we've solved both sides, 15 is another 12. Which side is greater? Yep. Write your correct symbol. The bigger side goes to the bigger number. Good? All right. Trace your number line. Mason, don't forget to write your symbol. Okay. And how would we read this? 0 is less than 15. Good. Trace your number line. Libby, how do we read that?
20.
Nope, this one.
A is greater
Greater than
than
or equal to.
plus 14
Good.
is
Nope, A is greater than or equal to 14 plus 14. New sentence. B is greater than or equal to 15 plus 15. And what is this R symbol mean? It means we're in the reals domain. Trace that R. All right. Last week we introduced the concept of temperatures and we talked about the boiling point for Fahrenheit and for Celsius. Do you all remember what the boiling point for Fahrenheit is? How hot does it have to be before the water boils, David?
20. 32.
Nope. Right here.
200.
What is that number? 12. So the boiling point for water in degrees Fahrenheit is 212. What's the boiling point for water in degrees Celsius? 100. So 212 degrees Fahrenheit plus 100 degrees Fahrenheit equals what? It stays the same, right? It stays 212. So that's your first blank. David, look here. Our sentence, 212 degrees Fahrenheit plus 0 degrees Fahrenheit equals what? If we're adding nothing, it just stays the same, right?
Yeah.
212. So Mason, you need to write 212 right here. In the blank.
Up here.
Yes, sir. Mason, use a pencil that works. I can't see it, so it doesn't count. Okay. Now, 212 degrees Fahrenheit is boiling for Fahrenheit, but 100 degrees Celsius is boiling for Celsius because they're a little bit different, right? So 100 plus 0 equals 100. Fill that in at the bottom. 100 degrees Celsius plus 0 more degrees equals 100 degrees Celsius. All right, Abby, are you done? 4Z. Okay. Yep. The next thing it says is circle the equal sign and the greater symbol. Mason, you stay with us, baby. Stop going all over the place. Circle the equal sign and the greater than sign in these columns right here.
I traced it.
Yes. Then we trace our matches. So that first one shows us a pattern. It ends with the ellipses. The second one is a sequence. See how it has no ellipses? Trace it. Here, this is what a pattern looks like. Mason, this is
the ellipses.
no, we're not adding ellipses. What we're doing in this is we're matching the term in the middle to the example on both sides. So we see here, this is what a pattern looks like. So trace that. Now, which one on this side is a pattern?
This one?
Yes, Mason. You matched that side, but now you need to match this side. Okay, now look on the left. We see what a sequence looks like. Just that, dude. Not hard. On the left side, we see what a sequence looks like. Where's our sequence on the right-hand side? Okay. Ready? Here, we're on sequence, baby, not pattern. This is a sequence. So where's the sequence on the right-hand side? Yes. Okay, this is called an operation. Matches the operation on the opposite side of this. And the last thing is called a function. Matched to the function. What's the difference between the operation and the function?
Operation is good, function is bad.
Why?
Because function is like plug. I'm plugged in, plugged.
No, that's not why. Our operation, look. Our operation is adding two digits. We know both of those. Our function has an unknown. It uses a letter. You see that? Here we have an operation. Those are two known numbers. A function is when, do you know what 41 is? Do you know what 61 is? So we know both those numbers, right? So that's an operation. A function is when we have a variable. That x, we don't know what that is, right? So it changes it. All right, please trace your, I guess, functions. Those are called functions because they have unknowns. Y equals x plus 4.
Well, x can also mean 10.
Y equals f times x, which equals x times 4. Yes, in Roman numerals, x would be 10, but in this case, we're not talking about Roman numerals, so it does not mean 10. All right, we're going to substitute and sum. So here, at the bottom, we see f30, so 30 plus 10 equals 40, f30, 30 plus 20 equals 50, f30, so we're going to put 30 in that last line. And what is 30 plus 30?
60.
Good. Write it after your equal sign. And the same thing with the tens. 10 plus, wait, pause. 10 plus 10 equals 20.
So I like 20.
No, we're here. 10 plus 10 equals 20. Here, 10 plus 10 equals
20.
20. And then fx equals, that first one is going to be, I'm sorry, f10. That first one is going to be that 10 from the f. Yep. And what's 10 plus 20? 30. Yes. So your answer, 10 plus 20 equals, Ayla, you can be excused. Thank you.
What?
So that is just where you transfer what it says the value of f is. So right here is going to be 10. Mason, you're going to write 10 right there.
For you.
10 is going in that first line, Mason. And 10 plus 30 equals 40. 40. Good. All right, last page. We have words, symbols, and images. Go ahead and trace your vector U.
A vector
And then your vector u
Vector
equals
equals 1.
angle brackets 1.
Vector equals 1.
And then the next one, we have the absolute value of vector u equals 1.
Vector plus vector is equals 2.
Good. The absolute value of vector u plus the absolute value of vector u equals 2. And then trace it on that number line at the bottom. Did you trace it on the number line? Good job. All right, go ahead and trace your x. The thing that starts with x right here. Under the horses. Oh, wait, pause, you're right. Let's go back up and do the horses first. Sorry. All right, as you all trace that, I'm going to read it. This is read as the limit of f of x plus g of x as x approaches a. Don't forget to trace the x approaches a under your first limit.
I did that for nothing.
Mason? You don't write anything there. You're just going to trace that next one. And as you trace it, I'm going to read it so you see what it sounds like. This is x approaches positive 42 from the negative direction. And then trace it on your number line. Okay? The next thing we have, we're working with an exponent. 10 to the third power, or 10 cubed, equals 10 times 10 times 10, which equals what?
1,000.
Good. Finish tracing that. Mason, go in order. Look at me. If you skip around, your brain is not going to learn it right. You need to go in order so your brain learns it in order. Okay? All right. 22 integral plus 24 integral. Look up here. We're going to do this together. Remember how we talked about, goodness, when we add and we have, when we add numbers that have multiple digits, we add our ones place first, right? So what's 2 plus 4?
6.
2 more than 4 is 6. So our 6 goes in the ones
I
place.
already did it, Mom.
And what's 2 plus 2?
6.
2 plus 2
2. 4. Plus 2.
is 4. So our 4 goes in the tens place. So 22 integral plus 24 integral equals 46 integral. All right, add your tally marks.
Let me tell my
It says, what is the unit? Tallies. How many is this?
5.
No.
I know.
How many is on this side of the plus sign? 8. 8 plus how many?
8 plus 8 is
How many?
19.
8 plus 8 is
16.
So you need to write 16 tally marks. How do we do 16 tally marks? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. In this problem, what is our unit? It's animals. So in our first problem, we had the unit of integrals. In the first one, we had units that were integrals. In the second one, we had tally marks. In this one, our unit is animals. So 4 birds plus 4 snakes equals how many animals?
8.
Yep.
6 cats plus 8 birds.
Bats.
Bats. I think equals 16. If 6 8
2, 3, 4, 5, 6, 7, 8. Good job, Mason. And then we're gonna add, so there's 8. Now we're gonna add 6 more. 1, 2, 3, 4, 5, 6. No, you're not showing it in tally marks. I'm just helping you see how we're adding it. Reverse your numbers. That's 41. That would be 1, 2, 4. That's 14. Good. All right. How many hundreds do we have?
200.
So write 200 in the blank under our hundreds.
Then we have 10.
How many tens do we have?
2.
2 groups of 10. So write 220.
Then we have 6. 1.
Well, 20. Yeah. And then we're gonna add it all together.
200 plus 20
Plus
6. I know. It's 226. 2.
Is that what you can say?
2